Everyone, welcome you all to webinar 2, the sustainable processes. With the knowledge gained from webinar 1, we will now learn about various sustainable processes for better housing. This webinar is divided into two parts. Part 1 helps us learn various sustainable processes and part 2 talks about thermal comfort and key stages to improve thermal comfort. The construction industry is one of the most prominent consumers of minerals and natural resources by its very nature. The need and significance of sustainability in construction have become a debated topic due to growing concerns over global warming and finite nature of resources. Sustainable construction involves using renewable and recyclable materials on building projects to reduce energy consumption and toxic waste. The primary goal of this initiative is to decrease the industry's impact on the environment by utilizing sustainable construction procedures, practicing energy efficiency, and harnessing green technology. While several companies from different business sectors are doing ways to be more environmentally responsible, many focus their attention on the construction industry since it is considered the largest user of global resources. It makes construction unique because by changing outdated practices, the industry can significantly reduce the effects of global warming. What are solar thermal panels? Solar thermal panels were the first solar energy products to be commercialized in the UK. These panels use the heat from the sun to produce hot water or steam. Like solar PV panels, these devices are also mounted on your roof to get as much exposure to the sun as possible. The sun's heat is used to warm the liquid that runs inside the tubes, usually glycol with antifreeze, and this is transported into your water tank ready to use. Installations aren't complex and can be added to an existing water heating system, compatible with both conventional boilers and immersion heaters too. The cost of solar thermal system varies, but normally you can expect to pay between 3,000 to 6,000 pounds. These figures include installation costs and all parts. There are three main sizes of solar panels to know: 60 cell, 72 cell and 96 cell. For commercial and residential solar panels, the 60 cell and 72 cell solar panel size are most commonly used, as the 96 cell measures 17.5 square feet, which can make a challenging fit on your roof. The standard size of solar panels are about 65 by 39 inches. The advantages of solar panels are: these devices can help you save on your energy bills by covering your heating needs, usually a totally free, clean and renewable energy source. The use of solar to heat water in turn reduces a consumer's carbon footprint, saving up to 600 kg of carbon dioxide emissions a year. Solar thermal panels are more efficient than PV panels due to waves of heat carrying more energy than waves of sunlight. In some instances, they can be up to 70% more efficient in collecting heat from sun rays than solar PV. Solar thermal is also more space efficient than solar PV. Therefore, it is perfect solution for smaller roofs. Solar thermal panels are relatively cheap to install. Some disadvantages of solar thermal panels are they have high initial costs. With any product of this kind, there is an initial cost of purchasing a solar equipment despite the financial return in few years' time. Solar thermal panels have some specific installation needs. While excess energy from sunlight can be stored in batteries, storing hot water for longer periods of time without a large loss of heat is trickier. These panels are not so aesthetic. Some people may find them unattractive. Now we will talk about solar PV panels. Photovoltaics is the conversion of light into electricity using semiconducting materials that exhibit the photovoltaic effect. The photovoltaic effect is commercially used for electric generation and as photosensors. A photovoltaic system employs solar modules, each comprising a number of solar cells which generate electric power. PV installations may be ground mounted, rooftop mounted, wall mounted or floating. The mount may be fixed or use a solar tracker to follow the sun across the sky. Photovoltaic technology helps to mitigate climate change because it emits much less carbon dioxide than fossil fuels. For residential solar panels, the standard dimensions are 66 by 40 inches for the panel, about 1.25 by 1.6 inches for the frame, and each panel usually weighs about 42 pounds. The average solar set will cost you between 2,500 to 8,000 pounds, including installation costs. This will vary depending on the panels you choose and the size of your roof. There are also solar roof tiles, These are much more costly than solar panels, between 5,000 to 14,000 depending on how many are needed. Now let's start with some of the advantages. PV panels have zero fuel consumption. Most homeowners choose to place photovoltaic solar panels on a rooftop where they are not necessarily visible from ground level, taking advantage of otherwise unused space and freeing up rest of the property for enjoyment. Unlike some energy delivery systems, solar PV energy is completely quiet and doesn't intrude into your daily activities. PV panels have longer warranty, about a period of 20 years. The drawbacks of PV panels are, with any product of this kind, there is an initial cost of purchasing a solar energy system despite the financial return in a few years' time. The more electricity you want to produce, the more solar panels you will need, as you want to collect as much sunlight as possible. PV panels require a lot of space and some roofs are not big enough to fit the number of solar panels that you would like to install. PV panels must be installed at an angle of 35 degrees for maximum productivity, so they are not suitable for all types of roofs. Air source heat pumps. Air source heat pumps are a kind of renewable energy technology that take the warmth from the air outside and use it to heat the home. You can get other heat pumps that do the same thing using the warmth in the ground and in water, but air source heat pumps are suitable for a wider range of properties. Because of air is heated by the sun, the energy that heat pumps produce is still classified as renewable, even though the pump itself is powered by electricity which may or may not have a renewable source. There are two types of air source heat pumps. Air-to-water systems are more common. They heat water which is then circulated around the home via radiators or an underfloor heating system. They can also be used to heat water in a storage tank for the bathroom or kitchen. Air-to-air systems typically use fans to circulate warm air around the home and cannot be used to heat water. There are various advantages to investing in an air source heat pump for your home. They have a significantly lower carbon footprint than more conventional heating solutions. With appropriate care and attention, air source heat pumps have a much longer lifespan than traditional systems, as much as 20 years. Air source heat pumps can be used for both heating and cooling. There is the option to use electricity taken from a solar or wind farm to power an air source heat pump. In the interest of helping you make the right decision, it's important to consider the following disadvantages of air source heat pumps. Radiators may be needed as air source heat pumps might reduce the heat supply in certain homes. Air source heat pumps are not suitable for all homes. To get the best energy savings possible, your home needs to be sufficiently insulated. Air source heat pumps are noisier compared to traditional boilers. Now let's go on to ground source heat pumps. Ground source heat pumps provide energy for heating and hot water by using stored solar energy from under the ground, a completely free and renewable source of energy. This system is often referred to as geothermal heating, and it offers many other attractive benefits. It is compatible with most modern heating systems. It is particularly suitable for underfloor heating, and the heat pump system can also be used to cool your property in summer. Some pros of ground source heat pumps are: they are eligible for grants. Ground source heat pumps are eligible for green energy grants, including the RHI and the more recent Green Homes grant. By making use of grants, you can lower installation and or running costs, making it an even more attractive investment. Ground source heat pumps are silent runners, so you or your neighbors will not be bothered by a noisy heat pump unit. They don't produce carbon emissions on site and don't involve the use of any fuels, and are therefore a good choice if you're looking for low carbon heating solutions. Additionally, if a sustainable source of electricity is used to power them, such as solar panels, they don't produce carbon emissions at all. They are safe and requires less maintenance. Here are some cons of ground source heat pumps. They are not suitable in areas with geothermal activities like mining. The installation costs of a ground source heat pump are considerably higher than the costs of installing a traditional furnace and air conditioner that requires a quite expensive initial investment. Ground source heat pumps are most common for new builds, but it can be a bit tricky to install in existing builds. Rainwater harvesting. Rainwater harvesting is the collection and storage of rain rather than allowing it to run off. Rainwater is collected from a roof-like structure and redirected to a tank, cistern, deep pit, aquifer or a reservoir. Rainwater harvesting is one of the simplest and oldest methods of self-supply of water for households. Installations can be designed for different scales, including households, neighborhoods, and communities, and can also be designed to serve institutions such as schools, hospitals, and other public facilities. In the UK, rain is readily available almost every single month. We love our summers and our warm British sun. But let's face it, we rarely wait a long time between rainfall showers. The good news is that when you put it to use through rainwater harvesting, even if that's just in the most simple way possible by using a water butt and collecting rainwater for your garden, you'll have a reason to smile when the rain breaks through every now and then. You'll realize the benefit firsthand, and then as much as you love the sun, you'll join us in telling people we love rain. The advantages of rainwater harvesting are they're easy to maintain. Utilizing the rainwater harvesting system provides certain advantages to the community. First of all, harvesting rainwater allows us to utilize an energy resource better. It is essential to do so since drinking water is not easily renewable and it helps in reducing wastage. Systems for the collection of rainwater are based on simple technology. Rainwater harvesting reduces demand on groundwater. With an increase in population, the demand for water is also continuously increasing. The result is that many residential colonies and industries are extracting groundwater to fulfill their daily demands. This has led to the depletion of groundwater, which has gone to a significantly low level in some areas where there is huge water scarcity. Rainwater is free from many chemicals found in groundwater, making it suitable for irrigation and watering gardens. During the rainy season, rainwater is collected in large storage tanks, which also helps in reducing floods in some low-lying areas. Apart from this, it also helps in reducing soil erosion and contamination of surface water with pesticides and fertilizers from rainwater runoff, which results in cleaner lakes and ponds. Rainwater harvesting systems have several disadvantages as well. Depending on the system size and technology level, a rainwater harvesting system may cost anywhere between 150 to 1500 pounds, and benefit from it cannot be derived until it is ready for use. Like solar panels, the cost can be recovered in 10 to 15 years, which again depends on the amount of rainfall and sophistication of the system. Rainwater harvesting systems require a regular maintenance as they may get prone to rodents, mosquitoes, algae growth, insects and lizards. They can become breeding grounds for many animals if they are not properly maintained. The collection and storage facilities may also impose some kind of restrictions as to how much rainwater you can use. During the heavy downpour, the collection systems may not be able to hold all rainwater, which ends in going to drains and rivers. Certain types of roofs may seep chemicals, insects, dirt or animal droppings that can cause various harms. Grey water. Grey water refers to domestic wastewater generated in households or office buildings from steams without fecal contamination. As grey water contains fewer pathogens than black water, it is generally safer to handle and easier to treat and reuse on-site for toilet flushing, landscape or crop irrigation and other non-potable uses. The application of grey water reuse in urban water systems provides a substantial benefits for both the water supply subsystem by reducing the demand for fresh clean water and the wastewater subsystems by reducing the amount of conveyed and treated wastewater. Some benefits of grey water include, with the use of grey water recycling system, the amount of water that was previously being used can be brought down to half. Water is known to be an essential asset for us. It is a resource that need to be conserved for generations to come, and in order to do just that, recycling grey water is the best option. Recycled grey water incorporates supplements that are supposed to be good for the growth of your plants. So make use of recycled grey water for watering plants. Heated water incorporates thermal energy, and this thermal energy goes down the drain each time we use water bathing, washing or utilize hot water for various other things. A grey water recycling system uses the thermal energy to warm new approaching cold water. This implies that its use reduces the measure of energy used up to 60%. The drawbacks of grey water are: diverted grey water can't be stored for a long time because bacteria can multiply, so it has to be reused immediately. It is necessary to have an additional storage tank to keep recycled water. All grey water has the potential to harbor dangerous viruses that cause health risks. Accidental cross-contamination of pipes can lead to drinking water contamination. Only a licensed plumber should implement changes to existing plumbing structures. Here is a brief video about grey water from a YouTube channel called Investing in Water.
Now moving on to green roof. A green roof or living roof is a roof of a building that is partially or completely covered with vegetation and a growing medium planted over a waterproofing membrane. It may also include additional layers such as root barrier, drainage and irrigation system. Container gardens on roofs where plants are maintained in pots are not generally considered to be green roofs, although this is debated. Rooftop ponds are another form of green roofs which are used to treat grey water. Vegetation, soil, drainage layer, roof barrier and irrigation system constitute green roof. Green roofs serve several purposes for a building such as absorbing rainwater, providing insulation, creating a habitat for wildlife and decreasing stress of the people around the roof by providing a more aesthetically pleasing landscape. This also helps to lower urban air temperatures and mitigate the heat island effect. Green roofs are suitable for retrofit or redevelopment projects as well as new buildings and can be installed on small garages or large industrial, commercial and municipal buildings. The term green roof may also be used to indicate roofs that use some form of green technology such as cool roof, a roof with solar thermal collectors or photovoltaic panels. Green roofs are also referred to as eco roofs, vegetated roofs and living roofs. Now let's move on to some advantages and disadvantages. The advantages of green roofs are they help in aiding air quality. Air pollution is a greater problem in urban areas, especially the larger cities such as London and Birmingham. A green roof helps to improve the overall air quality. According to a study, green roofs help reduce up to 37% of sulfur dioxide, 21% of nitrous acid, and zero point 0.2 kilogram of dust particles per square meter each year. Without doubt, one of a green roof's most beneficial advantages is its thermal performance, and it's staggering just how much of a difference that can make. By implementing a green roof, you can ensure to improve energy efficiency and limit the usage of air conditioning too. Plants absorb the sun's energy and therefore reduce the temperature of the roof in summer, whilst aiding thermal efficiency in the colder winter by locking heat inside. Green roofs are compatible with photovoltaic installations as well. A rooftop is continually under attack from the elements and has plenty to cope this throughout the year. Not only will a roof need to sufficiently deal with the wind and rain, but ultraviolet light and fluctuating temperatures too. As such, it's common for both homeowners and business to consider an alternative option for the roof. Green roofs offer this opportunity and have proved to double or even triple the life expectancy of your rooftop. The barrier of greenery helps to protect the waterproof membrane underneath and ensure your rooftop's life expectancy lasts well for decades. Now, here are some disadvantages. Unfortunately for green roofs, they do tend to be slightly more expensive than the traditional option. One of the significant reasons for this being the extra support required to handle the increased load. There is no doubt about it, green roofs are heavier and as such require more structural support to be implemented. Rooftop will be needed to be retrofitted to cope with the increase in load. There seems to be much debate as to the full extent of maintenance required for the green roof. However, what's clear is you will need to do some work to ensure it remains a thriving atmosphere. You should treat your green roofs as a garden and such it will require watering, feeding and weeding. Finally, let's see heat recovery ventilation, also known as mechanical ventilation heat recovery. It is an energy recovery ventilation system which works between two air sources at different temperatures. Heat recovery is a method that is used to reduce the heating and cooling demands of the building. A heat recovery system is designed to supply conditioned air to the occupied space to maintain a certain temperature. A heat recovery system keeps a house fully ventilated while recovering heat being emitted from the inside environment. In general terms, a domestic heat recovery and ventilation system could cost between £2,000 to £7,000 depending on the amount of work needed, the fixing of pipework for example, and the size of the premises. The pros of heat recovery ventilation are reduced carbon footprint, and heat recovery ventilation is one way that you can reduce the carbon footprint created by your home and do your part for the environment. This is because their design is incredibly efficient. The system is made up of two fans, one to expel old air and one to bring in fresh air from outside. During this process, around 85% of old heat is retained. Heat recovery ventilation system also reduces carbon dioxide levels. Modern homes are built to be airtight in order to retain heat in the winter and stay cool in summer. Consequently, they require a moisture control system to prevent the buildup of pollen, mold, mildew and other contaminants. It also works around the clock to expel moist air and replace it with clean, fresh air from the outside. Since waste heat recovery often leads to significant fuel savings, it reduces carbon footprint. The drawbacks of heat recovery ventilation systems are: adding a heat recovery ventilation system to your home can be expensive. You will need to run ductwork throughout the house to bring fresh air into the house while exhausting stale air to the outside. Whole house systems are generally installed in new homes but can be retrofitted into older homes if the ductwork already exists. The cost of installation will vary depending on the size and style of the heat recovery ventilation system. One potential downside is that an heat recovery ventilation system does require some space. It requires high maintenance as the filters must be changed once every 6 months to a year. It is not suitable for flat roofs as well. Here is a video on heat recovery ventilation system from a YouTube channel called Zero Energy Buildings Learning Center. Moving on to part 2, we have thermal comforts. Thermal comfort is a condition of mind that expresses satisfaction with the thermal environment, taking into account a range of environmental, work-related and personal factors which helps in deciding what makes a comfortable workplace temperature. And U value is one of the factors which is useful for deciding. So let's talk about it. U value or thermal transmittance. What is U value? It identifies how eligible they are at blocking the transmission of heat between inside and outside the building. Good insulated structured buildings have lower U values compared to other structures, or simply the lower the U value, the better insulated the building element. U value is a reciprocal of the resistance and its unit is watt per meter square Kelvin. Here are the building regulations according to UK government. Here you can see the U value of domestic and non-domestic buildings. For example, let us see the U value of a new build. Here the U value of the roof must be 0.14, while U value of walls should be 0.22, and so on. Now let us learn how to calculate the U value. For example, let's calculate the U value of a 230 mm thick wall with 12 mm plaster on both sides. For that, firstly, we have to calculate thermal resistance of the brick. Thermal resistance, or R, is a measure of the opposition to heat transfer by the particular component and is obtained by dividing thickness of the material with thermal conductivity. Thermal conductivity or K value measures the ability to conduct heat. You can get the material conductivity on the internet. Same way, resistance is to be found for the plaster. RSO is the outside surface resistance and RSI is the inside surface resistance. Moreover, the RSO and RSI value is known. Hence, we can calculate the total resistance RT by adding everything. Since plaster is added on both sides of the wall while calculating total resistance, we should add it twice. After obtaining the total resistance, lastly U value is calculated by reciprocating the total resistance. Here are some key features that you could include in your building designs prior to investing in the process mentioned above. These key features helps to improve thermal comfort in a building. A draught lobby is an enclosed space given at the opening of a room or a building so that the air entering the building can be minimized when we open and close the door. So if we provide these type of facilities, it will prevent the unwanted entry of dust, pollutants and will also filter the air entering our house. This will give us comfort and also provides healthy indoor environment. Moving on to some advantages, they include energy savings. By preventing the infiltration of the outdoor air, a draught lobby can help to reduce the amount of energy needed to heat or cool the building, resulting in lower energy bills and a reduced environmental impact. Also, by reducing the amount of outdoor air that enters the building, a draught lobby can help to keep indoor air cleaner and healthier by reducing the amount of dust and pollutants that can enter. A draught lobby can help to maintain a more consistent indoor temperature, which can help to improve occupant comfort and reduce complaints about thermal discomfort. It can also provide an additional layer of security by creating a controlled entry point, allowing for the screening of visitors before they enter the building. Moving on to building insulation. Building insulation is a material or a combination of materials used to reduce the flow of heat between the interior and exterior of a building. It is typically installed in the walls, roofs, and floors of a building and can come in many different forms, including blown-in, spray form, and rigid form. Advantages of building insulation include 1. Energy savings. Insulation can significantly reduce heat loss in the winter and heat gain in the summer, which can result in lower energy bills and a reduced greenhouse gas emission. 2. It can help to create a more comfortable indoor environment by reducing cold spores and drafts, which can make it easier to maintain a consistent temperature and reduce temperature fluctuations. Next, it can help to reduce the amount of noise that enters and leaves a building, which can create a quieter and a more peaceful indoor environment. Insulation can help to reduce the amount of condensation that forms on the inside of walls and ceilings, which can help to prevent dampness and mold growth. Lastly, it can help to reduce energy consumption and greenhouse gas emission, making it an environmentally friendly choice for the building. It also helps to reduce the demand for fossil fuels, which can help to reduce air and water pollution. Here is a video from the Energy Saving Trust that illustrates building insulation.
We should all feel safe and warm at home. But heating can be expensive. And your gas or oil boiler creates carbon emissions. An extra layer or two can help. Insulating your home keeps the heat in and the cold out, maintaining a constant temperature whatever the time of year, which brings down your bills and your carbon emissions.
Then we have double glazing. It is a type of window or door that consists of two glass panes separated by a small gap filled with air or an insulating gas such as argon. The two panes are sealed together to create a single unit, which is designed to provide better insulation and reduce heat transfer through the window or door. Furthermore, advantages of double glazing include energy savings. Double glazing can significantly reduce heat loss through window and door, which can help to lower energy bills and reduce carbon emissions. The insulating properties of double glazing also helps to keep building cooler in the summer by reducing heat gain. The gap between the two glass panes in a double glazed unit provide additional sound insulation, which can help to reduce external noise and create a quieter indoor environment. Double glazing can provide an additional layer of security by making it more difficult for intruders to break through the windows or doors. It can also help to reduce the amount of condensation that forms on the inside of windows and doors, which can help to prevent dampness and mold growth. Double glazing can also help to create a more comfortable indoor environment by reducing cold spots and drafts near windows, which makes it easier to maintain a consistent temperature. Here are the video courtesies. And that's the end of webinar 2. I hope you understood the different sustainable processes discussed in this webinar, which you could use for your designs as well. We hope to provide more insightful information through our upcoming webinars, so look out for them. Until then, we wish you all the best as you take part in this